Hi everybody, this is Konstantin Läufer, your programming languages instructor from Loyola University Chicago. And in this video we're going to work with a project that we check out from version control. And we'll start again with our welcome screen. If you're not seeing this, you might be looking at an actual project which you can close. And then you're back at the welcome screen, so we can say check out from version control. And we're going to work with a GitHub project. And the first time you try to check out a project from GitHub, you can enter your GitHub credentials. And you can choose to save the password. There's also a way to do token-based authentication. That's also a good choice. So log in. And now it wants some kind of master password, so choose something that you'll be able to remember. Well, you can always reset that stuff. So anyway, now it's going to talk to your GitHub account and get your list of available repositories. And if you pull down this little menu here, you should see whatever repositories you have. If you don't have any GitHub repositories, what you can do is visit the example. So in this case, we're going to work with the echo test example. And there is a clone URL here on the lower right. And you can clone directly from that. In fact, a better choice even would be to create a fork of the example into your own GitHub account and then use SSH to check it out, using an SSH-based URL, because then you can actually make changes to that fork and commit those changes to your fork. And if you think that those changes are valuable contributions to my code, then you can submit a so-called pull request. So that's all documented on the GitHub site, and we're not going to go into this further at this point. But the key thing here is that you can copy the clone URL here, either of the original or then of your fork, and then insert that here as well. So it doesn't have to be a URL that you choose from this drop down. So instead I'm going to insert, whoops, somehow I had something else copied, so let's make sure we press this button here. So now we should be able to insert this, yep. And now there's a little test button here, so we'll try that. And this succeeded, so that's good. And now we'll be able to do a local clone directly into IntelliJ of this repository. Okay. Now it gives us the option to open it. Yes, we'll do that. And now there's a similar SBT configuration screen as when we created an SBT project in the other video. So again, here we're going to check these first. Well, actually, really only the, let's see, well, I would say the first one and then the third and the fourth one, because presumably the project that we're checking out already has directories, all the directories that it needs. And now here, let's choose the project SDK that we know we have available, so the 1.8 SDK. And the rest should be okay as is, so we don't even have to drill into that. And now we'll hit OK. And it's supposed to process the SBT build file and import the project. All right, so here we go. And we can now open a project view with on Apple Command 1, or we could just say View Tool Windows Project. And we'll see a similar kind of thing here. And SBT is still doing some work down here, as you can see. So meanwhile, we'll browse the code base a little bit. And the structure is again very similar. You have the src main and src test. And this is a very, very simple example. So it helps to understand how a Scala SBT project is structured typically. So here's a main method. And right now it's still processing and indexing this project because very soon it'll, let's see, it'll make these different menu items available that it discovers based on the indexing. See, so now it actually, before, see how it had the source files here under main, and now it shows the actual Scala program elements. So there's a trait, which is a little bit like a Java interface, actually more powerful, but it replaces that construct. And then there's the main object, which is the app. And what this does is simply create two implementations of some kind of echo class, and then for each of them it will invoke the echo method on it. So we could run that, so we could either right click right in here, see the run main, or we could right click or context menu click on the node on the left in the project view, and we can run that. So it's compiling and it'll run it shortly. Again, there are some steps in here that take a little longer because they're a one-time thing that has to happen first, and then subsequent times will go faster. Okay, so the simple echo echoed hello once, and the double echo echoed hello twice, using that same echo method, and both implementing this echo trait. You see here how this is like an interface. It specifies an abstract method. And then the simple echo implementation is here. It just returns its argument, and the double echo returns the argument with some spaces in between. Okay, so that's simple enough. Now we'll take a look at the tests and how to run the tests. Okay, so most of you will be familiar with Java's JUnit or a similar testing framework, and we'll just focus on that. And this is assertion based. By the way, most of my examples have these embedded Java or Scala doc comments that you're encouraged to read because they provide some guidance. So here's an import. It imports some stuff from org.junit library, and the underscore is like a wildcard, kind of like the asterisk in a Java import. Okay. Now these are simple test methods with assertions, and here, for example, it asserts that simple echo applied to the string hello should return hello, right? In JUnit, the expected value goes first, and then the actual value goes next. And here, the double echo, it's expected to return hello, hello, with some space in between. And then there's a little bit of other stuff here, and we'll take a look shortly. So how do we run this test? Well, we should be able to do the usual thing. So we'll bring up the context menu on that node, and here indeed it allows us to run echo JUnit, and we'll see what happens. Okay, so we got some tests that didn't pass, and here we see, well, it performed 6 tests and 3 out of those failed, which is good because we want to see the kinds of failures we can get. And in fact, there's a button here, a toggle. If we turn this, you see when we hover over it, it says hide pass. That's why it shows only failed tests. If we hit that, it'll show the passed ones with the passing ones with a green OK. And now there is a distinction between an orange exclamation mark and a red exclamation mark. Okay, so let's take a look. The orange one here, for example, double non-empty, we can look at the explanation and it says, okay, there's a comparison failure because of this assertion here where it asserted equality, so it has to compare the actual, the expected and the actual values, and it said it expected hello with 1 space and then hello, but it actually got hello 2 spaces and then hello, and we can look at the implementation of the so-called subject under test, the SUT double echo, and sure enough, you know, there are 2 spaces here, see, 1, 2, and that's the reason. So how do we fix this? Well, obviously, you know, you'll first verify, you'll double check that the test is correct, but then you have to fix the subject under test, not the test. So this would be the right place to fix. All right, very good. So test double empty is a similar kind of thing. There is also some kind of comparison failure, and this is you know, a little non-obvious, but again, here on the left there's a single space, and here on the right there happen to be 2 spaces. So similar thing, you know, when MSG is empty, you still get the 2 spaces here, and in the test it was expecting 1. You see here 1 space. Okay, that explains that. Now let's take a look at this test that has a red exclamation mark here, and you see the difference here. So there's an exception that occurred before, and here it tells you the line numbers where this occurred. So echo JUnit line 37, we can actually click there to navigate there. So why did this fail? Well, because the list indices start at 0, and there's 1 item in the list, an instance of simple echo. So that's why this indexing into the list with an index that was too big failed. So this is an error that occurred before we could even do a meaningful testing of an assertion, which would have been the next step, but it didn't get there. So that's the key distinction here. So a failed test in terms of a failed assertion will show up with an orange exclamation mark, and there you'll want to look at the reason why the assertion failed. But a red exclamation mark indicates a much more serious condition, an error that prevented a meaningful test to complete with a pass or a proper fail result. Okay, so that's the main distinction here. To wrap up, well, the other examples are to illustrate some other test frameworks. In particular, this one here uses Scala test, which supports various different styles of testing, and there's a link in here that you can follow to look a little bit at the Scala test documentation. Scala test is really the recommended framework for using any kind of test-driven or behavior-driven approach in Scala. So the JUnit is there just to make the transition easy for those of you coming from JUnit. And the others illustrate some other choices. There's an interesting one called, an interesting approach called property-based checking. So here it'll use this kind of logical for all or universal quantifier that says, well, it kind of abstracts or generalizes the kind of stuff that for which we just had a few specific test cases to the general property that we really expect these subjects under test to fulfill. So we can say, well, how should simple echo behave? Well, for any string, it should return that string. And this is a way to express exactly that. And then double echo for any string, it should return that string followed by one space and then followed by that string. So it's very powerful, and you might wonder, well, how does it do this? Well, for basic types such as numbers and strings, it has built-in default generators that will create, let's say, an empty string and then some kind of random string of length 1 and then a string of length 2 and so on, and it'll just iterate through the values that it gets from the generator, and it does a certain default number of iterations. So here typically, if we run this, it'll do, I think, 100. Let's run this, and it runs either that default number of iterations. So for simple echo, see, it worked for 100 tests that it generated automatically, and for double echo, it failed immediately because, as we noticed earlier, even for the empty string, it'll return the 2 spaces because of that error in that implementation. So this style is called property-based checking. This is quite powerful, and there's this possibility of using Scala check, which is a property-based testing framework, or we could use that same style within Scala test. So here you have basically 3 different test styles: the JUnit style, the Scala test spec-based style, which is actually I meant this one here, the this one, which is similar to the JUnit style, and then we have 2 flavors of the property-based style, direct use of Scala check, and then this echo check, using basically embedding that style within Scala test by pulling in these checkers. Okay, so that's basically a very brief overview of testing in Scala. And of course, in a given project, you're not expected to use all these different styles. So it usually agree with, within your project team on a particular style and follow that. So this is really just to illustrate that there are these different possibilities. And you see how it basically makes Scala, the test source folders green and the production source folders blue, once it's done with the indexing and all that stuff, which which is no problem here. So then a couple of other things I wanted to show that have to do with the way SBT works. So you might wonder, well, aren't these test frameworks external dependencies, libraries? Yes, they are. That's actually a good point. And if you look at build.sbt, so this is a very simple configuration file for the build, and this is where those external dependencies are specified. So you could say, well, I want to add some library dependencies, and these are listed right here. So that's how it works, and it downloads those dependencies. In fact, it downloads the transitive closure of the dependencies, meaning the dependencies of the dependencies and so on, until every dependency has been resolved. The entire dependency graph has been pulled in, and then it constructs a Java class path from all that. So that's definitely not something you'd ever want to manage manually. So that's why this kind of build tool is so valuable. Okay, and then the The other thing I wanted to show is this Git Ignore, because the way SBT works, similar to these other tools like Gradle and Maven, there's a target folder which has all of the generated stuff. And guess what should not be done with the generated stuff, like the bytecode files? They should not be added or included in version control. So that's the key reason you want a Git Ignore file. Similarly, the idea configuration, which is really also generated from the build.sbt using IntelliJ's capability of importing SBT projects directly, that should not be part of version control either. So you should always have a Git Ignore. You could probably have just one at the top level folder or directory of your repositories. You could also, if you have your own separate projects, you want to have one Git Ignore per repository, per Git repository. So let's take a quick look, and sure enough, it excludes the kind of stuff that we want to exclude, like .idea, target, class files, so other generated files. Here's some stuff for Android. Okay, so very important, always make sure you have a proper .git ignore, and there are examples around, or you can just take one from one of my examples. Okay, this is it for now. So this should get you started in checking out a project from GitHub and running that and doing the tests on that. Okay, we'll be back shortly.